Okay, welcome to the second lesson of quadratics. The main purpose of today is the big skill that we did in grade 10 called completing the square. As you can see in the learning target, that's not the only thing we're going to do today. We want to talk about finding maximum value of a quadratic with any strategy. They're really the best strategy, and completing the square is a really nice strategy. It gets us from standard form to vertex form. But we don't need standard form, we don't need vertex form to find the vertex. And so we just recognize that you can do that in factored form as well. So question for the warm-up, and you can pause the video just to try these three questions on your own. So the question is, how do you find the vertex from each of these following forms? So I'll let you pause it right now. Okay, so for the first one, we actually determine its factored form. And so if it's factored form, it actually tells you the zeros. The zeros are x equals 3 and x equals 5. And the vertex is right between them. For this example, it's very easy to understand. Between 3 and 5 is 4. If we sub in 4, we actually get negative 1. And so we sub in 4 and get negative 1. And that is actually your vertex. So that's the y value when you're on the axis of symmetry. And so we got the vertex is 4, negative 1. And so it looks like this. And so basically what we've done is seen the two zeros, the x symmetry right in the middle. We sub that value into the equation to get the y value. The second one is actually in vertex form, so it can easily be understood that if you sub in x equals 4, that's the simplest number to sub in. And what your answer is, negative 1. And we know from transformations that basically what's happened is the vertex has been shifted right 4 and down 1. The third one is standard form, and since we haven't done completing the square yet, so what we actually do is that's the graph. We actually factor it, and so we can factor it to x minus 3 times x minus 5, and we can see that it's actually the same as the first one. And actually, all three of these are the same quadratic. This is a quadratic that nicely goes standard, vertex, and factored form. And so one of the key things that we're going to do we have to do in this unit is convert from form to form. However, I'd only actually be worried about converting from standard form to vertex, which is what we're going to do today, or standard form to factored, which we spent a lot of time on last unit, factoring. And we will spend more time doing it now. So we start off with some of these examples. I always like to ask this question, what form do you think this is in? And so you can actually think about it. So that form is actually in both forms, factored and vertex form. And so if you think about a vertex form, it's actually the vertex is 2, 0. It's just shifted from 0, 0 to the right 2 to get 2, 0. The second one actually factors very nicely. 2x minus 3 times x minus 3, and this really captures the idea that there's the factored form, but that's the vertex form as well. And the vertex is just 3, 0. The third one, we kind of say, well, we could factor out the x and find out the axis of symmetry, but this is where we're going to start talking about completing the square. So we actually ask ourselves, look, what's the number on the end that would kind of make it factor nicely like this? And we kind of anticipate from b that it's plus 9. If we put plus 9 on the end, it would factor nicely. We can't just put plus 9 on the end, so we actually subtract 9 as well. And then when I put quotes around factors, because we're really factoring it by grouping now. We just factor these three, the trinomial part, the first three things, to x plus 3 squared minus 9. That's very similar to b, except it's shifted to the left instead of right, and it's shifted down 9 as well. And the vertex here is negative 3, negative 9. Okay? Two more. So we look at this one, and this one, the plus 9 does not allow it to factor nicely like that. So what we do is we talk about completing the square. And so really we only care about these first two terms, x squared minus 4x. X squared minus 4x need a plus 4 on the end so that it would factor nicely. If we add 4, we subtract 4 as well. and then it would factor nicely as minus 2 times minus 2. We'll talk about where the plus 4 comes in a minute. And so this is x minus 2 brackets squared minus 4. And so basically what this does is it replaces the x squared minus 4x. So these two numbers here actually just like we showed, and we'll actually show it inside the calculation on the next one, but they replace the x squared minus 4x, and then when combined with the 9 you get plus 5. And so you can easily now find the vertex when you plug in x equals 2, y equals 5. The next one, we don't want it in this form with the 2, and so we actually take the 2 out so that it looks more like this. So we take the 2 out, and we actually and if you can't take the 2 out, like if it's not an even number there, like if that was a 9, we just force it out by dividing. So, and I mean, I'm okay if you actually use decimals. I'd encourage you to use fractions, but like if it's the difference between you understanding it and not, I don't mind you using decimals. So we divide the 8 by 2 to get 4, and then we do the complete the square part, which we actually showed before, x squared minus 4x plus 4. So we add the 4 and subtract the 4. Notice how we do it inside the brackets. We're completing the square on x squared minus 4x. So if we add 4, we got to subtract 4 both inside the brackets. Now to get the negative 4 out, we have to multiply by 2. And so the only thing we did here was 2 times negative 4 is negative 8. You can see where decimals will actually help here, because this can be a little bit complicated with fractions. And then we can factor the x squared minus 4x plus 4 to x minus 2 squared. And the minus 8 and plus 5 go to minus 3. Okay. So when I say completing the square, what we're actually doing is factoring. So we complete the square and then we factor. So it is a type of factoring. Now it's in vertex form. We could draw this as a step pattern of multiplied by 2, so it's vertically stretched by 2. So the vertex is 2 comma negative 3. Okay. There's a bit of algebra there. I mean, you could repeat those steps too. Like that's basically the steps that we need to do to complete the square. Again, like decimals are gonna, like non-even numbers are gonna complicate things, but you can use decimals if that's gonna be the difference between not getting it. But I encourage you to use fractions. I just think, but I definitely don't mark it wrong if there's decimals. So the question is, you might have been asking, like, where did that plus 4 come from? Where did the plus 9 come? Plus 9 come from in the last one? So the question is, how do you get the last term? So when you have the quadratic in this form or this form, you can, by factoring out the a value. So like we've got two different forms here. I just use the same letter, even though I could probably call this b over a. Like the last term, which completes the perfect square trinomial and allows you to factor into vertex form, not looking at the c, like kind of putting the c on the outside, is b divided by 2 squared. So where we got the 4 was we divided the middle term by 2. So we took this b and divided it by 2, and then we squared it. That's why I didn't change the b to b over a. Like I just want to like emphasize that we're just taking this number here, whatever it is, whether it's inside the brackets or not, or like with a simple trinomial, not. It's just divide this number by 2 and square it. Okay. So look at a question here, like a golfer attempts to hit a golf ball over a gorge. So you've got a model here where h is height in meters, t is time in seconds. So this is a ball being launched in the air. Power lines are 185 meters above the ground, directly in the path of the ball. So that just assumes that if the ball is going to go 185, it's going to hit the lines. And so, I mean, that's all that's saying. Will the golf ball hit the power lines? So the first solution you can actually do is not actually completing the square, it's factoring. We could factor out the negative 5 completely, use a simple trinomial to factor t minus 10 and t plus 2. Determine that the zeros are 10 and negative 2. They look like this. And so I always like to graph them, because even just a sketch, because like if we can put negative 2 and 10 on a number line, it just really helps us understand, like, just so we don't make a mistake, that where the middle is. And we suspect it's like around 4. And so the axis symmetry is right in the middle. It's when we add these two up and divide by 2. We're just basically taking the average of these two numbers, 10 and -2, and we get 4. And that makes sense. Like if you got a number like 2 or -4, you could see it on the number line. And so the axis symmetry is right in the middle there at t equals 4. That's just a vertical line. When you sub in t equals 4, you can sub it into the factor form. Is usually nicer to sub it in. 4 minus 10, 4 plus 2. So we get -5 times -6 times 6, which is 180. So your vertex, the highest height is actually 180 meters, so it will not hit the lines. Just won't go up high enough. Just to draw a little graph, so you can. That's the solution, but I just put the graph on top of that. You've got the quadratic that actually doesn't exist here. Like it actually starts at a height of 100, so you're like on top of a platform. So that's what the platform above the ground means. The ball hits a height of 180, misses the power line, and then back down, hits the ground at 10 seconds. Okay. Second solution is actually completing the square. And so we factor out that -5. We don't want that -5 there. We don't have to take it out of the 100. It's just extra work if you do. So just leave the 100 alone. That's not going to help you complete the square if it's not already a perfect square trinomial. Take the 8, divide it by 2, and square it. We get 16. So we add that 16 and subtract it immediately. So all we did was put the plus 16 and the minus 16 in there. Get the -16 out by multiplying it by -5. So all we did here was get the -16 out, change it to plus 80. That's where the 180 comes from. The middle guy factors t minus 4, t minus 4. You don't have to show that step every time. Like you understand it factors to t minus 4 squared, which is actually half of the 8. That's helpful as well. It has to be half because it is a perfect square. It has to be the square root of 16. So this 4 has to be there. And so then we've got vertex form. You can argue this is actually a shorter method if you're good at this. And like if you want to avoid the factoring, certainly I wouldn't do this method if it was already factored. I would want to use the zeros and then the midpoint of the zeros. So again, we've got a max height of 180. And there's the graph again. It's the exact same. Okay. So either way, so you can see the quadratic shifted to the right 4, up 180. It's vertically stretched by a factor of 5. That's how it gets up so high, but only going 6 to the right and 6 to the left. Last one is done purposely. It's not really a nice solution, although the 3 actually factors out nicely. So I did this actually in 2 ways. If you want to challenge yourself to use it with fractions, or if you want to do it with decimals, we're going to just follow the solution down on both sides. And so the first one is actually the same on both ones. We factor up the 3. Leave the 2 alone. You don't have to take 3 out of 2 by dividing 2 by 3. It just makes it more complicated. Leave the 2 alone. You get this number by halving the 3 and squaring it. So if we half 3, we get 3 over 2. And then squared is 9 over 4. So since 3 over 2 squared is 9 over 4, we add 9 over 4 and subtract 9 over 4. Alternatively, you can write 9 over 4, just do 1.5 squared, get 2.25 in the calculator, subtract 2.25 right away. Multiply out the -9 over 4, you get 3 times 9 over 4. So you can see where it can get tedious with fractions, because now you're multiplying a fraction by a whole number. In the other one, you're just multiplying it 3 times 2.25, which is just 6.75. Okay. The third one factors to x plus 3 over 2. So it's the square root of 9 over 4 is 3 over 2. And then 9 over 4 times 3 is 27 over 4. And I changed the 2 to an 8 over 4. Just to add the fractions, we just use a improper fraction. The other one's a lot easier. I mean, you're just subtracting 6.75 from 2 to get negative 4.75. And then we've got our quadratic in vertex form is x plus 3 over 2 squared minus 19 over 4. Negative 27 plus 8 is 19 over 4. You can write this as a mixed number if you like, or you can just leave it like that. I think to graph it eventually you want to kind of say that this is this is 4 3/4. You might want to say that this is 1 1/2, just to understand that like what it looks like on the graph. So you can see this is why I don't really argue with students about using decimals, because to graph it, you can argue that this is actually easier to graph anyway. And in this case, because we're only because we have terminating decimals, these are exact values. You're not actually rounding at all. And I wouldn't recommend to round if the numbers aren't too long. If they go, and if you do have to, I'd go to 4 decimal places. Fractions are better because we as mathematicians don't really know how the scientists want to use it. We don't know how many decimals they want to use. It could be an engineer, it could be somebody using this calculation for something really important where they need very close accuracy. Just imagine if the units were in meters. We would want to get very, very close. Or if the units were in millions of dollars, we wouldn't want to we don't want to round to the nearest $1 million. And so that's why fractions are good. But if it's going to prevent you from learning it, I'd like you to demonstrate it with the decimals. Okay, and so your vertex is either one, negative 3 over 2, or negative 1.5, and then 19 over 4, or 4.75. Okay, and so there's your practice.